Hello, this is Enrique, West High Physics DoD STEM Ambassador for First Robotics, and today I'm going to be doing a quick example of how to find particles in the data, sort of like the Higgs boson. So if you're following along, you hopefully watched the video. This is just going to be a quick help video for this lesson. Okay, so I'm going to be importing. First step, so I've made a Jupyter Notebook in Google Colab, and I'm going to import the libraries. Okay, it doesn't look like it's done anything, so let's just make sure pi is there, because that's how I'm going to check to see if it worked. It did work, so when it imported pi, there you go. Okay, so now I can use this pandas function that reads in CSV files. I'm just going to go ahead and read the penny mass data, which we went over before. So it said play, and it feels like it did it. So how do I check? Let's just type in data and see what we have here. So we have 150 data points, 2 columns, year and mass, penny. And I want to make a histogram of these guys. So what's the command for histogram? Well, I'm going to be using a matplotlib command called plthist. And the way plthist works is, you can see here it tells you need X and then bins and then range. So I'm just gonna I'm just gonna copy that and put it in here. So how this is gonna work is, instead of writing, so this is like what the parameters you put into your function is. So range, the way let's do with X. So X is gonna be the data, and so in this case I want to pull histogram of the mass, okay? The mass. So how would I call that? Well, it's in the data with the column mass. So I have to replace the X in there with data, and then I put brackets. By the way, if you're doing it right, it shows up things over here. So then it quotes mass, okay? So that's going to be that column. Bins, so it defaults to 10, but you can put in any number of bins. Let's put in 10 bins so that you can see what the default looks like. And then the range, let's see if this works. I think this will work with, there's no range yet. So here's the penny mass data with 10 bins and no range specified. So it's like the whole data set, basically. So let's change the range. So it looks like it ranges from like 2.4 to 3.2. So how would I do that? That's like, I'm going to put brackets there for the range. The low number is 2.4, comma, the high number, 3.2. So if I do that, I get a very similar looking graph. It's only slightly modified, but you can see that it's kind of adjusted it a little bit. It's not like exactly the same, but you see 2 peaks here. So if this was my particle information that I'm going to be reading and using in my assignment, how would I find peaks? So maybe I should use more than 10 bins, right? Maybe if I use 20 bins, it gives me a higher resolution, because okay, there seems to be a peak somewhere in here around 2.5. Let's use 20 bins for this range. See what we get. So you can see there's 20 bins. The number of counts here has decreased from 10 bins. So if you look over here, there's 50 in this peak, but over here there's like 20 over here around a little less than 2.5 now. So if I go back to 10, see how this is close to 40? It's just saying that there's 40 events somewhere between 2.45 and 2.55. But I want to have a higher resolution for my peak, so yeah, so one thing I could do is change number of bins, and that will give me a better estimate for whether the peak is actually happening over here. But another thing I could do is change the range. So I can change the range. I don't have to look between the whole thing. I'm only interested in what's going on near 2.5. So so my low range might be 2.4, and my high range might be like 2.6, let's say. Okay, and this is now, it's not going to leave the bins the same size. It's going to make 20 bins in this range. So watch. see how there's now 20 bins in this range. So the most number of counts in a single bin, it looks like 8. There's 8 around here at a little bit more than 2.5. There's a lot right at the edge, right? So I could maybe change the bins again so I can get 10. That's going to give me more counts. So I definitely, it looks like I have a peak right there at 2.5, like 1 or something like that. Like it's kind of hard to resolve. So again, maybe I should zoom in some more. Maybe I should zoom in from 2.45, 2.55, and each bin, since I have 10 bins, each one's worth 0.01, right? So it's kind of, this might be an interesting graph to look at. So again, it has the 3 in there. So there seems to be like some sort of, something happening at 2.5 and 5, 2.5, no, 2.505, I was gonna say 2.51, something like that. So if this was if in your assignment, you're gonna be looking at collisions in the Large Hadron Collider, actual data from that. And if, let's say this was, I'm going to pretend now this was Large Hadron Collider data. And let's say I found a peak. I actually like the other graph better because it was a more definitive peak. I don't remember what my parameters were for that. I think it was this, right? Let me go back to this. Let's say I find a peak there. That looks very peaky at 2.51. So great. I've discovered a particle here at 2.51, let's say. How could I figure out what that particle is? Well, so the next step would just be to Google what particle has mass 2.51. And the units in the particle physics are not kilograms, but they're GeVs. So this is what you have to type into Google to figure out what it is. Now, it says the Z particle has 80 GeV. So that's not, and like, here's one that's 125, right? So there's no particle at 2.5 because this data set is not actually the Large Hadron Collider. It's penny masses, right? And so like, what if I had typed in 125 GeV? That's called the Higgs boson because a particle with mass 125 was discovered in the Large Hadron Collider. So again, the data set that you're given is not going to include Higgs boson, but anyway, this is how you would figure out the assignment. So what your job today to do is to change the number of bins and the range to hunt for some particles. And there's quite a few particles inside of the data set. There's more than one. So there's more than one Nobel Prize that was discovered here for using this histogram method. Okay, so a little bit of motivation for you. Find out a little bit more about your particle and report back when you're done.